All right, in this video, we're going to try to work through this inverse trig integral example. Now, right off the bat, how do we even know that this is an inverse trig integral? Well, usually we're not going to be told what is and what isn't an inverse trig integral. They'll just, on a test or in a homework, give us an integral and just say, compute it. And it might be an old technique like U substitution or the log rule, or just some old basic integration technique, or one of these newer advanced integration techniques with the inverse trig function. So somebody might not initially see this as an inverse trig integral. They might think, I would very well expect somebody to think like log rule, because you have a fraction, you have one polynomial over another one, and so you might have this setup of like du over u, which would be the log rule. But we quickly see if you let u equal t to the fourth plus 25, the du would be 4t cubed. And we don't have a t cubed, we have a t. And so while that was a good idea to try, it's not actually going to work. It wouldn't actually lead to too much of anywhere. But what I do realize is that this guy looks very much like the template for the arctan integral. One thing that caught my eye was in the denominator here, I had something squared plus something squared, and that was my flashing red light that, hey, this is likely an arctan integral. Now, one thing that might confuse me at first is in the numerator I've got a t, not a 1, as I often have. For arctan integrals, oftentimes there's a 1 or a constant in the numerator, but here I've got a t. So we'll have to see how that plays out, but nevertheless, I think this is worth pursuing. So let's see here. What's our a and what's our u? Well, u is the function with the variable, a is the term that's the constant. So if this is a squared, then a would be 5, and if t to the fourth is u squared, then u should be t squared, right? Because t squared squared would be t to the fourth. Okay, so that means when you rewrite this integral here, we would have in the denominator, it doesn't matter how you order the terms, you would have a squared plus u squared if you flipped them around, which is totally fine to do since it's addition, and so that fits. Now what goes in the numerator though? It should be u prime. So if u is t squared, then u prime would be 2t dt. Now I've got a t dt, but I need a 2t dt. So what I'll do is, this is a very common trick, you probably remember this from Calc 1, very often we will insert a constant of some kind, and then we will balance it on the outside with the reciprocal of that constant, so that we haven't changed the expression, we haven't changed the integral. If you pulled this 2 outside the integral, it would cancel with the 1/2, and it's like it was never there. All right, but nevertheless, the 2t dt, this will become your either u prime du, or however you want to say it. There's still a 1/2 on the outside. Okay, and this fits the template perfectly now. We can put a du here at the end if we want to be careful about how we're writing this. And so we compute the integral, and the integral final answer would be 1/2. That's this tag along 1/2 that's already on the outside. We would have a 1 over a, right? 1 over a, so 1/5 arctan of u over a plus c, because it's an indefinite integral. And the last small thing you could do, obviously I'm not going to rewrite this, but the 1/2 and the 1/5, you could call it 1/10. You could just multiply those. But that's how we do this indefinite integral here, and just trying to show you a very common trick of how your numerator might not be a constant. It might in fact be the derivative of your u expression that's in the denominator.